Let's go ahead and look at more examples here, okay? A little bit more different than what we have seen so far. Let's say you have this rational expression, 8z minus 24 over 4z minus 12, okay? So your first step involved is factoring your numerator and your denominator. So let's see. Between 8z and 24, you can pull out a greatest common factor. You can see 8 will go into 24 as well. So if you can pull out the 8 as your greatest common factor, you're left with z from the first term, and then 24 divided by 8 will give you 3. You'll do the similar kind of thing for your denominator. You have 4z and 12. Again, 12 will go into 4 3 times, so we can pull a 4 outside as our greatest common factor, which will leave me with z minus, again, 12 divided by 4 is 3. Now this example is slightly different, as you can see. In this case, your common factor turns out to be a binomial term here. So you have z minus 3, which is common. You can go ahead and cancel that out. You're left with 8 over 4. You know that 8 will go into 4 twice, so you can actually go ahead and reduce that down further, and you're left with 2. Okay, so that basically tells you 8z minus 24 over 4z minus 12 will reduce down to a 2. In its lowest terms, it's going to be the number 2. Alright, looking at another example here. You have 16x squared minus 9y squared over 12x minus 9y. Again, you start out by factoring your numerator and your denominator. Now, if you can recognize here, you will see your numerator is a difference of squares. As you can see, 16, you can write that as 4 squared. The x is already squared. 9 you can write as 3 squared, and then y, of course, is squared again. So if you try to rewrite this problem, you could write this as the first term, you could write it as 4x and then the whole thing to the second power, minus, you can write the 9y squared as 3y to the second power. Okay, and let's see what happens in your denominator here. You of course can see you don't have a difference of squares in the denominator, so you will have to go back and see if there's anything common between the two terms. Now you have a 12 and a 9, and you know both of these numbers will go into 3, so you can actually pull 3 outside as your greatest common factor, just like you did in these example above here. So if you pull 3 outside as your greatest common factor, 12 divided by 3 will give you a 4. You still have your x. And then 9 divided by 3, of course, gives you 3, and you still keep the y. Okay? Now, all we did so far is rewrite our numerator. We haven't factored it. So now, in the next step, we will go ahead and factor this out, and this will be difference of squares. So remember, 4x plus 3y, 4x minus 3y for your numerator. And then the denominator, we of course already factored it out, so you're left with 3 times the quantity 4x minus 3y. So again, if you will notice, you have a whole binomial term which is common between your numerator and your denominator. 4x minus 3y is common, and you can go ahead and cancel that term out. And let's see, what are you left with? In the numerator, you have 4x plus 3y. And then in the denominator, all you're left with is 3. And from this point, you of course cannot reduce it any further. So this is in your lowest terms. Let's consider one more example here. In this one, we have trinomials that we're trying to write in the lowest terms. In this case, you have 3x squared plus 8x plus 4 divided by 3x squared minus 4x minus 4. Now again, you need to go ahead and factor these terms out. So you want to see how you can split your middle term and factor these two expressions out. So let's start with the numerator here and see how we can factor our numerator, and then we'll look at our denominator. So let's look at 3x squared plus 8x plus 4. Okay. Now when you're working with trinomials of this form, the idea is you first multiply your leading coefficient with the constant term. So you multiply the 3 into the 4, which gives us 12. Okay. And then the idea is to find factors of 12, which will of course multiply to give you 12 but add to give you 8. Okay, so you're trying to split your middle term. So 12, you of course have 12 times 1, 6 times 2, 3 times 4. Now if you look at 6 and 2, when you multiply 6 and 2 you get 12. When you add them you get 8. So that's what we are going to use here, these two numbers, to split our middle term. So instead of writing it as 8x, we will go ahead and write it as 6x plus 2x, and then the first term and the last term will of course stay the same. Okay, once you split your middle term up, again remember we want the expression to stay the same. You're just trying to factor this, so you have to break up your middle term. Once you do that, you will go ahead and group the first two terms and go ahead and group the last two terms. And just like you did earlier, within each group you want to try and find a greatest common factor that you can pull outside. So if you have 3x squared and 6x, 3 and 6, of course 3 is common. Okay, and then you have an x squared and an x here, so you can pull one x outside as your greatest common factor. And that will leave you with, if we took the 3 outside, that's gone. We took one of the x outside, so you're left with just one x. Plus, if you divide 6 by 3, you end up with a 2. And we already took that x on the outside, so it's gone. So you're left with x plus 2 inside the parentheses. That is your first group. Then you go ahead and put that positive sign in the middle. And now look at the second group and do the same thing. Find your greatest common factor. So between 2 and 4, 2 of course will be a common factor. You don't have x on both the terms, so we cannot use x here. So only 2 will be your greatest common factor. When the 2 goes outside, you're left only with the x. And then of course 4 divided by 2 gives you 2. Now another thing you can keep in mind when you're going through this process of factoring is that this parentheses and this parentheses both have to be the exact same. You cannot have different numbers in there. You cannot have one positive, one negative. They have to be identical, okay? Once you come down to this step, now the idea is you have x plus 2 in both these terms. Go ahead and write that as your greatest common factor, okay, because that's common between these two terms. And then whatever you're left with goes in the other set of parentheses, okay? So you take the 2x plus 2, combine it together as 1, and then whatever terms you had outside, including that sign, you put that in a second set of parentheses. And this is how you factor 3x squared plus 8x plus 4, okay? So we will go ahead and write this down for our problem here. X plus 2, 3x plus 2, okay? you will do a similar thing for your denominator expression. So your denominator is 3x squared minus 4x minus 4. Okay, 3x squared minus 4x minus 4. Let's go ahead and factor that out. Same thing, you multiply the 3 with the last term. This time you have 3 times negative 4 because your last term is a negative now, which will give me a negative 12. Okay? Now you need to find factors of negative 12, which will add up to give us the middle term, which is a negative 4. So let's see what will work this time. Two numbers that will multiply to give us negative 12 and add to give us negative 4. Let's see, how about maybe a negative 6 and a positive 2. When you multiply negative 6 with positive 2, you get negative 12. And when you add negative 6 plus 2, you end up with a negative 4. So this will work really well for our example here. So let's go ahead and split our middle term again with negative 6x plus 2x. And then your last term and the first term stay the same. Okay? Exact same thing that we did earlier. Same process. Go ahead and group the first two numbers or terms. Go ahead and group the last two terms. Pull out your greatest common factor, which will be 3x again. And 3x, so you're left with just 1x on the inside, minus 6 divided by 3 will give you 2, and the x is already gone outside, so x minus 2. Same thing on the other side. Go ahead and put the plus in the middle. Between 2x and 4, 2 will be your greatest common factor again. And this time you're left with x minus 2 inside the parentheses. Again, notice the two parentheses, exact same, okay? Identical. Go ahead and put those two together, which will give you x minus 2. And then the terms that were left outside will go in your second set of parentheses. And 3x squared minus 4x minus 4 will factor out into x minus 2, 3x plus 2. Okay, so the denominator is x minus 2, 3x plus 2. Now once you factor your numerator and denominator, then go ahead and see which ones are the common factors, and then, using your fundamental property, go ahead and cancel those out. So here you can see 3x plus 2 and 3x plus 2 are your common factors. You cancel those out. And in lowest terms, this expression will be x plus 2 over x minus 2. So as you can see, you need factoring for simplifying these problems down. And once you do that, then all you're really doing is trying to find your common factors, canceling those out, and whatever is left is your expression in its lowest terms. You have to be careful when you're working with these sort of problems. Sometimes we tend to make really simple mistakes and get the whole problem wrong. For instance, let's look at this example here. Now remember, you cannot write a rational expression in lowest terms until after you have factored your numerator and denominator. Before factoring the numerator and denominator, you cannot start canceling things out, and a lot of people tend to do that. Like in this example, you have 2 plus 3x over 3x. You are adding 2 to the 3x in the numerator, whereas in the denominator you have only 3x by itself. You cannot cancel the 3x's out and come up with an answer of 2. That is not correct because you haven't factored your numerator or your denominator. So you cannot do this. You want to be careful about that. You will not get 2 as your answer. For that matter, this expression is already in lowest terms. You cannot reduce it down any further. So be careful when you're working with these problems. Okay, let's look at a couple more examples here with writing an expression in lowest terms. Now, the idea is if the numerator and denominator of a rational expression are opposites, then the rational expression will equal -1. Now, when we say opposites, we're talking about something like this here. You have 2 minus k over k minus 2. Let's say we're trying to put this in lowest terms. What will we do? Let's look at, maybe we'll go ahead and rewrite either our numerator or our denominator. So let's say we want to rewrite our numerator. Now you have 2 minus k over k minus 2. If I rewrite my numerator, remember you have negative on the k, so that gives you negative k. 2 is positive, so that becomes negative k plus 2, and the denominator stays the same. All I have done is just changed where I put my k and my 2. I haven't, solved anything here. Now what I will do is, since my k is negative, I want to make it a positive k. For that, I will factor out a -1. Okay? When I take that -1 outside, my k becomes a positive and my 2 becomes a negative. Okay, your signs change basically anytime you pull -1 outside as your greatest common factor. My signs change, all right, and my denominator, of course, stays the same. You will see what happens here. Once I did that, you have k minus 2 common between your numerator and denominator, so you can go ahead and cancel those out. And all you are left with is a -1 on the numerator and a +1 on the denominator, which is the same thing as just saying -1. Okay? That's what this statement here is talking about. When your numerator and denominator are opposites, the rational expression is equal to -1, and you can see what happened here. So when you're talking about opposites, they're of course going to be of the form 2 minus k over k minus 2, or you basically switch the order of the numbers here. Let's look at another example on how to work with these opposites here. Here you have z squared minus 5z over 5z minus z squared. So you can already notice that these are, in different orders here. Now let's say we'll start out by factoring our numerator and our denominator. You have z squared minus 5z, so you can see z is common between both our terms here. So you can pull z outside as your greatest common factor, and that will leave you with z minus 5. On your denominator, again, z is common between the two terms, so if you take the z outside, you're left with 5 minus z. Okay? Now this is z minus 5, 5 minus z, so they're not exactly the same, but you can definitely cancel out your z's here, and that leaves you with z minus 5 over 5 minus z. And it's now at this stage, it is very similar to this example that we saw, as you can see here. Okay, so you can already conclude this is going to be -1, but let's just go ahead and solve it just to be sure. Okay, so let's say we want to rewrite our denominator this time. We will leave our z minus 5 the same, and we'll rewrite our denominator, which will give us -z plus 5. Again, I'm just changing the positions of the -z and the 5, and this will give me, numerator stays the same. Pull out a -1 as your greatest common factor, and when you do that, the signs will change. Z becomes positive, 5 becomes negative. Okay, So again, z minus 5 will cancel out. You're left with 1 over negative 1, which is the same thing as negative 1. Okay? Now, you didn't really have to go through all these steps. I just wanted to show you, if you work it down, you will still come up with the same answer, but you could have seen right here, you had z squared minus 5z and 5z minus z squared. You can see how they just switch the order of the two terms here, and the sign in the middle, of course, stays the same. If you can recognize this pattern, then you know your value, or in lowest terms, this is going to be a negative 1. Let's look at this example here. 5 minus x over 5 plus x. Do you think these two are opposites of one another? Is this the same thing as what we have seen in the first two examples that we did? Are they opposites, and will they reduce down to a negative 1? Okay? Think about it. We said here in these examples that we did, your sign in the middle has to stay the same, and then the two terms switch sides. In this case, your terms are still the same. 5 and x are in the same order. We haven't changed their order. The only thing different between the two expressions is one is negative and one is positive. So that tells us this is not an opposite. Okay, 5 plus x is not the opposite of 5 minus x. You will not be able to reduce this down any further. This term, or this expression, is already in its lowest terms. You cannot do anything else to this expression here.